In this video we're going to look at paragraph 5.3, which basically wraps up the quadratic equations. I've already written down 4 of them, which are actually really hard. I'll discuss them in a minute. The second part of this paragraph is more about the applications of these quadratic equations. It's a pretty difficult part, I'll admit. And I want to use part 2 for that because it will be a pretty long one, I think, but we'll see. If you already think that you can solve these 4 equations by yourself, you might give it a try. You can also just not pause the video and listen to me if you prefer to hear my voice. So yeah, by now you've had enough time to actually pause it, I think. So yeah, let's go. This first one, when I see it, the thing which catches my attention is that this is a square, 2x minus 5 squared, and 36 is also a square, which means that we can basically take the square root of both sides. So that means that 2x minus 5 is equal to 6, or 2x minus 5 is equal to minus 6. Because remember, 6 times 6 is 36, minus 6 times minus 6 is also 36. Okay, then we're going to basically use the balance method to solve this. So 2x is equal to 11, which means that x is equal to 5.5. And on the other side we have 2x equals minus 1, which means that x is equal to minus 1/2. So that's the first one. That was the easiest one of these 4, I think. The next one, there are brackets, and well, this is a product of 2 things, but this is not 0, so we have to remove the brackets and later on we'll add them, I think. So 2x times x, that's 2x squared. 2x times minus 3, that's minus 6x, which is equal to x minus 9. Usually when you want to solve these things, you want to move everything to one side. This is an exception to that, only because we have 2 squares. So if you move everything to one side, we have 2x squared minus 7x plus 9 equals 0. Then there are 2 options. This might look like a quadratic equation one. Is that going to work, and is that actually convenient? Yes, I think so. So let's start with A, B, and C. A is 2, B is minus 7, and C is 9. So now discriminant is equal to b squared minus 4ac. Keep that in mind. So minus 7 squared minus 4 times 2 times 9. This is 49 minus, let's see if I'm not lying to you right now, 4 times 2 times 9, which is 72, which means that right now this is minus 23. Since our discriminant is negative, we have no solutions. So even though if I wanted to have answers, well, they're not here. Okay. Something tells me I did something wrong. Let's check it really quick. Did I copy it correctly from my workings? For some reason I only wrote down equations. I didn't solve them beforehand. This all seems to be correct. This seems to be correct. That seems to be correct. This is correct. I don't think I did make a single mistake here. Let's move on. this case there are brackets and fractions, which means first I'll remove the brackets. You can also remove the fractions first, but it's basically whatever you like. This is 1/4 of x squared minus a quarter times a half is 1/8. X equals 1. Okay. If I multiply everything with 4, this is removed, but this isn't. So I'm going to multiply everything with 8, which means this becomes 2x squared minus x is equal to 8. Move this to the other side, so 2x squared minus x minus 8 is equal to 0. And then I'm going to use the quadratic formula again, and a is 2, b is minus 1, and c is minus 8, which means that the discriminant is equal to minus 1 squared minus 4 times 2 times minus 8. This is 1 plus 64, which is 65. And yes, which means that there are actually solutions because d is positive. So if I want to find the solutions, let's take x is equal to minus b. So it's 1 plus the square root of 65 over 2 times 2. Or x is 1 minus the square root of 65 over 2 times 2. And then I need a calculator because the square root of 65 is probably close to 8.1, but it's probably not exactly that. And I do want the correct answer for you guys. Should deserve the best. Let's see if this is 2.27 or x is about 2.27 or it's about 1 minus the square root of 65. I haven't seen him. Which is minus 1.77. Was a small break, it's okay. Then the last one. First we're going to remove these brackets, so 2x squared minus 5x minus 7x plus x squared equals 15. 2x squared and 1x squared is just 3x squared. Minus 5x minus 7x is minus 12x equals 15. I want to move that to the other side as well. So 3x squared minus 12x minus 15 equals 0. All of these things are multiples of 3, which means I can divide all of these things with 3. So I'll get x squared minus 4x minus 4 equals 0. And then I can use the product sum method actually. X minus 5 and x plus 1 equals 0, because minus 5 times 1 is minus 5 and minus 5 plus 1 is minus 4. So now x minus 5 is equal to 0 or x plus 1 is equal to 0, which means that x is equal to 5 or x is equal to minus 1. So as you can see, there are multiple ways of solving these things, and just try and figure out the easiest way of solving them, and that's usually by removing brackets first, later on adding them, knowing when do you use a product sum method, when do you use the quadratic equation. Anyway, you'll be solving another set of quadratic equations, so good luck with that, and hopefully you'll manage to do it.